Right now, far beyond the planets, far beyond the protective reach of the sun, an ancient spacecraft is still speaking to Earth. Voyager 1 is not supposed to be doing this. It was built in the 1970s, before modern computers, before the internet, and before most of the people studying its data were even alive. It was designed to last a few years, fly past Jupiter and Saturn, send back images, collect measurements, and then disappear into silence. But it never stopped. It kept moving. It crossed the edge of the solar system. It entered interstellar space. And now, from a place no human-made object had ever reached before, Voyager 1 is telling us something that does not fit the models. The space beyond our solar system is not quiet. It is not smooth. It is not the empty black ocean we imagined. It has a hum. It has turbulence. It has a violent boundary wrapped around our solar system like a hidden shield. And the strangest part is this. What Voyager 1 found out there is not only about deep space. It is about us. Because the same boundary Voyager crossed is the barrier that helps protect Earth from the raw radiation of the galaxy. So when Voyager 1 looked back across that frontier, it revealed something we cannot fully explain yet, something that may change how we understand the survival of life inside the sun's bubble. Voyager 1 launched on September 5, 1977. Its original mission was simple: visit Jupiter, visit Saturn, take photographs, gather data, and complete one of the most ambitious planetary flybys ever attempted. That was supposed to be the story. A brilliant mission, a few years of operation, and then silence. But Voyager 1 became something else. In 1979, it passed Jupiter and sent back close-up images and measurements that changed our understanding of the giant planet. In 1980, it passed Saturn, revealing details of its rings, moons, and magnetic environment. Then gravity did the rest. The outer planets did not just give Voyager 1 targets, they gave it speed. Each flyby acted like a gravitational slingshot, throwing the spacecraft farther and faster into the dark. By the end of the 1980s, Voyager 1 was already farther from Earth than any human-made object had ever traveled, and it was still alive, still transmitting, still measuring, and still sending its thin radio signal across a growing ocean of space. Then, in 2012, Voyager 1 did something no human machine had ever done. It crossed the heliopause. This is not just a distant region beyond the planets. It is the true outer edge of the sun's influence, the place where the solar wind finally loses its strength and interstellar space presses inward from the other side. Everything inside that bubble belongs to the sun, the planets, the moons, the asteroids, the comets, Earth, and every living thing that has ever existed. But outside the heliopause is something else entirely. The space between stars, the ancient plasma of the galaxy, the region shaped not by our sun, but by the wider Milky Way. When Voyager 1 crossed that boundary, it became the first human-made object to enter interstellar space. And because it kept transmitting, humanity suddenly had something it had never had before, a live instrument on the other side of the solar system's wall. And what it found there was not what the models predicted. For decades, scientists built models of what interstellar space should be like. The expectation was not that it would be perfectly empty. Space is never truly empty. But the plasma between the stars was expected to be thin, cold, and relatively smooth, a quiet background outside the sun's protective bubble. Then Voyager 1 entered it, and the quiet disappeared. Starting in 2017, Voyager 1's plasma wave instrument began detecting a persistent narrowband emission, a hum, a faint continuous vibration in the plasma of interstellar space. It was not a single burst, not a temporary shock wave, and not one suspicious reading that could be dismissed as noise. It was a signal that continued year after year across an enormous distance as Voyager 1 moved deeper into the space between stars. This is where the discovery becomes extraordinary, because that hum gives scientists a way to measure the density of interstellar plasma continuously. Before this, researchers could only get scattered snapshots, often when solar eruptions sent disturbances all the way out to the boundary and caused the surrounding plasma to respond. That was useful, but incomplete, like trying to understand the weather of an entire planet by measuring one storm every few years. Voyager 1 changed that. The persistent emission became a kind of running feed, a real-time trace of the interstellar medium around the spacecraft. And what that trace revealed was unsettling. Interstellar space has structure. It has density changes. It has turbulence. It has motion and complexity at scales that older models did not fully capture. The universe beyond the solar system is not a calm waiting room between stars. It is active. It has texture. It behaves almost like cosmic weather. And Voyager 1 is the only spacecraft inside that weather measuring it directly. But the hum still raises a major question. Scientists are still working to determine exactly what physical process creates it. It may be thermally excited plasma oscillations, natural vibrations inside the plasma, or it may be quasithermal noise, a different mechanism that could reveal density and temperature in a way that forces models of the interstellar medium to be revised. Either way, the message is the same. The space outside our solar system is more complicated than we thought, and Voyager 1 is detecting it before we fully understand what it means. The hum was not the only surprise. Before Voyager 1 fully entered interstellar space, it crossed the heliopause itself, the boundary where the sun's solar wind meets the pressure of the galaxy. Scientists expected this region to be unusual, but many models imagined a relatively gradual transition, with solar particles thinning out while interstellar particles became more dominant.